Hi, everyone. Welcome to Deep Dive. So today we're going to be focusing on the Embedded C SDK for constrained devices. If this is your first deep dive you've been to, welcome. We're excited to have you. So what deep dives are is we're actually going to go in and do a technical walkthrough and describe best practices with working with a new feature. So today we're actually going to be deep diving into the Embedded C SDK. If you're not aware of what the Embedded C SDK is, we're going to give an overview of what it is shortly. But just to kind of give a little bit of background, we did release at Microsoft Build the Embedded C SDK and public preview. It's great for constrained devices. And if you've already been working with the C SDK, you're going to be super interested in this new product that we are offering. So I'm going to go ahead and introduce our speakers. So we have Dane. He's one of our software engineers. Hi, Dane.
How's it going? Yes, my name's Dane. I'm a developer on the Azure IoT SDK for C team.
All right. And then we also have another speaker here, Wellington.
Hey, Pamela. I am Wellington, and I am the PM responsible for the C SDK and now for the Embedded C SDK as well.
Yes, and Wellington and Eric was actually, we just did an IoT show episode that we released at Microsoft Build to give an intro of the Embedded C SDK. If you haven't watched that, I really recommend watching that. So let's go ahead and jump into the agenda. So for the agenda, we are actually going to go through an overview. So Wellington's just going to give, what is the Embedded C SDK? Why did we create this? And how it's better for microcontrollers, and some ways to get started. And then we're going to go into the Embedded C SDK overview. So we're going to dig into the GitHub repo. We're going to go through some samples. We're going to talk about, we're going to go through some samples like with device twins, direct methods, device to cloud, sending telemetry. So we're going to go through all of that. And Dane is going to be going through those samples, but he's also going to talk about kind of best practices when he goes through the examples. And then we'll end with resources. So how do you get started? Where to go to learn more, where our docs are, to ask questions, how to get a hold of all of us. So we'll dig into that shortly. And then just keep in mind, deep dives are live events. So if you're in the chat right now, ask questions, because we're going to be in the chat. We're going to be able to answer all of your questions that you ask. And if you're viewing this deep dive on demand, don't worry, because we will show how to get in touch with us after the event. Wellington, did you want to give an overview of what is the C SDK, and then what is the Embedded C SDK?
Absolutely. Yes. Thank you, Pamela. So the best way to tell our story for embedded is really to see the C SDK and the Embedded C SDK side by side. And as you can see here in this slide, we do have the C SDK under what we're calling scenario 1. And here, as you can see, the C SDK works as this platform connecting your application to Azure IoT Hub. And it provides pretty much everything a developer needs to get that connection going, from the hub client, options for transport, options for TLS, and socket. But while this is great to provide all of these features to our customers, there is a trade-off here, which is size. And size was exactly one of the things that we considered when thinking about how to create a SDK that would fit to these tiny devices, and most of the times devices that wouldn't be connected to Wi-Fi, or devices that wouldn't be close to a power outlet, so they would have to rely on batteries or solar power. And that's what you can see here on the scenario 2, the Embedded C SDK for constrained devices. So by looking at the differences here, you see that while the Embedded C SDK is still providing all of the functionalities that we were providing with the C SDK in terms of having telemetry, so device to cloud, cloud to device, device twin methods, and device provisioning, we are giving the developers the choice and the freedom of choosing whichever MQTT client they would want to use. This could be Paho, Mosquito, or any other. Same goes to TLS, and the same goes to Socket. So in this scenario here, you see that a customer could be looking at a specific embedded platform, and they would be using MQTT, TLS, and Socket that were designed specifically for that platform, for that microcontroller. And this way, they would get to the best and most optimal way to optimize for size, optimize for power consumption. And so truly, when we look at this embedded CSDK, we're looking at all of the embedded best practices. So things like optimizing for size, providing customers with a choice. We are steering away from dynamic memory allocation. We're fully embracing MQTT. And this is what we like to consider our everywhere SDK, meaning that if you have a device that can connect to a network, it is very likely that you'll be able to run the embedded CSDK on it.
Wellington, you made mention of that you're fully embracing MQTT. I do have a question. What about MQTT 5? Is that going to be supported? Is that supported now?
That's a great question. It is not supported right now because the IoT Hub currently is not supporting it, but that's obviously on the works because this is going to be an industry standard pretty soon. So as soon as we have the support on the Hub, the embedded CSDK will support that as well.
Okay, and then so it looks like you have the two options, C SDK and embedded C SDK. And I've worked a lot with partners and customers with the C SDK. It sounds like the biggest benefit is really the footprint and moving to the embedded C SDK, especially if you're working with different microcontrollers like the ESP32 or other microcontrollers. I'm wondering, what is our support though for the C SDK? So if I'm running the C SDK on ESP32, will I still have long-term support for the C SDK, or should I be migrating to this embedded C SDK?
This is really up for the customer to decide which option will be better for them. We are going to be supporting both. So this is not a replacement, it's an additional to the CSDK family, which is the reason why, as you can see here on the slide, we still have under the scenario 1, a good case for Linux and Windows, so no constrained devices. Now, if the customer are thinking in terms of going to very small footprints, or if they just want to leave more space for their applications, yes, considering the embedded CSDK could be the best option for them.
Okay, perfect. And I see Azure RTOS is playing a part in this. So if I'm already working with, Azure RTOS, and all of the different components like ThreadX and all of them, when will that convenience layer be available for me to work with?
Oh, that's a good point. The embedded CSDK is a part of Azure RTOS. So for customers using Azure RTOS today, this is already on public preview as well. So we do have what we're calling this convenience layer, which is a wrapper for the embedded CSDK to enable all of these functionalities for Azure RTOS as well. So this is already out there in public preview.
Okay, sounds great. And it sounds like the same support that we'll have for the embedded CSDK will still be the same for the CSDK. I'm guessing that's for any bug and security fixes.
Absolutely,
okay.
Yes. We're still focused. We're pretty much now working with on both. So the same level of attention and issues, and if there's any bug fix or any security issue, we're working on both.
And then I know we mentioned this on IoT show episode, but I am getting asked a lot about this, is the plug and play support, and what is the story there before we jump into the samples?
Oh, absolutely.
Yeah.
So there is no PNP support on the embedded CSDK today. We do have that in public preview for the CSDK, but we are definitely looking to bring also the PNP capabilities to the embedded CSDK by the time we are GAing the embedded CSDK on late August.
Okay, perfect. And I know we again, before we go to jumping into Dane going through the samples, I'm curious on your slide, you have the developer's choice, and there's different options for developer's choice. But I'm interested in what is some of the guidance that we're going to give in the getting started guides. So maybe this is a question better after we show samples, but I'm just curious, are we going to be showing getting started guides with each one of those different options, or are we just picking the top options? Just interested.
Got it. Yeah. Well, probably not with every single one of them or every single combination, right? Because that would require a lot of different samples. But yeah, definitely we're gonna show some of these scenarios right now on the samples. And we want to create this reference implementation in which we're going to be showing how to build a solution and how to pick and choose the MQTT, TLS, and socket. And obviously, because this is also going to vary from platform to platform. So if you're using this, say, on a Linux environment, this will be different if you're using, as you mentioned, right, the ESP MCU. So for different MCUs, we'll have a different platform, and eventually we will use a different combination, right? But definitely we will have some of them covered on the samples and definitely on the reference implementation as well.
All right. Well, thank you, Wellington. I think we're going to go ahead and just jump into Dane going through the samples, going through the technical walkthrough and giving us what are some of the best practices and just how to get the machine set up, telemetry, go over device twins and direct methods samples. So thank you, Wellington. Dane, do you want to go ahead and jump into the GitHub repo, and we'll be answering questions in the chat.
Absolutely. We're going to start off by going to the vanity link for the Embedded C SDK to see where that takes us. And here we see that we are in the Azure SDK for C repo, which houses a lot of SDKs for Embedded C. For today, we're going to go over IoT. And so here we have tagged for the preview too, and this is the main page for all the IoT stuff. So this is all the key features that we are currently supporting. Here's some examples of using the code in various different ways. But the thing that we specifically want to tackle today is going into Hub and going into the Hub samples. So here we have a README going over how to get started to get these samples running. And so that's basically what we are going to jump into today. So starting here, getting started, there are a couple of prerequisites that we are assuming people know. For example, like having an IoT hub up and running. So I have one of those. The other thing that is going to be very useful for people to have open is their IoT Explorer to interact with their devices and monitor outgoing or incoming telemetry, C2D, all that kind of stuff. So those are two very useful things to have up and running. So here we can basically just start following this getting started guide. And so the first thing that you're going to want to do is have actually VC package installed and ready to use to manage the dependencies, because in this example, like Wellington mentioned, we are giving people the freedom of choice to choose their stack. And in this case, we chose PAHO MQTT. It's widely used and it works well for Linux and the Windows samples. So basically the directions for that are where'd they go? Right here. So what you're going to do is you're basically going to clone VC package, you're going to bootstrap it, and you're going to install the dependencies. We specifically want PAHO MQTT. So if I were to do that here, I'm not going to do it because it takes a little bit of time to actually install that. So I would be in my VC package directory, I would do bootstrap VC package, and then after that, I would run the command. I have these just copied over for sanity's sake. So here you would run VC package install the triplet, the platform that I'm running. I'm running on Windows Subsystem Linux and PAHO MQTT. So I run that. It basically will say you can now use this as a CMake target, which is what we're going to want to do. So once you have that set up, what you're going to want to do is point your CMake to that VC package config. which it details right here. So you're basically going to have this export saying this is the platform I want to use, and then you're going to want to have your path to the VC package repo, which I have, like I said before, I have these just easily so I don't make any typo mistakes. So I'm going to go cd back to my repo here for the SDK. I'm going to paste in, this is an export used for building. And then I also have my export for the location of the VC package that I'm using. Cool. So now we're going to go there. At this point, what you're going to do is set up the certificates that we have in this repo. For convenience sake, we have, let's go back here, source. So we have generate certificate script that basically will generate self-signed certs for you to get up and running quickly. So you don't have to go into the details here at all. Basically, what we can do here is we can go into, let's see, SDK, IoT Hub, samples, SRC. And here you see we have generate certificate. I don't have any certificates in here, so all I'm going to do is /generate certificate. And we get a lot of stuff spat back out to us. So the main things that you're going to want to pay attention to are, because we're on Linux, we don't need to have this root trusted cert. But here we want to point the samples to the cert file that is generated for us. So as it says here, use the following command to set the environment variable for the samples. So I'm just going to copy that and paste it here. So there I have the exported. And the other thing that you're going to want to pay attention to is this fingerprint, because on IoT Hub, you're going to need this to paste in for self-signed certificate. Let's see, for self-signed certificate devices. So let's go in here. So at this point, I am creating an IoT device to connect to Azure IoT Hub. So once this loads, I'm going to go ahead and select new. I think here I have, yes, build-demo. So I just gave a name, build demo, self-signed. So this is where you're going to want to have that thumbprint. So you're going to paste it here, and you're also going to paste it as the secondary too. So if you're here, then you can go ahead and hit save. And boom, so now we have a device. So just to confirm, we have build demo right there. So we're ready to connect. It's disconnected right now, but that's because we're going to connect it later. So let's see, once we have that, then you're also going to want to basically have 3 different exports for the device. Now, the reason why we did this is previously we've had, you can paste in a string or a connection string, or you can paste it in your cert. What's nice about this and using these environment variables is that it doesn't muddy your samples, and you don't accidentally push that to a GitHub repo where people can use those. So by using these environment variables, we actually make it a little bit safer to use these samples. So for example, we have easy IoT device ID. So I'm setting the device ID for the device that I want to connect, which I do there. And then I also have the host name for my IoT hub, which is back over here, right there. So I just have that copied over. So let's go here. I have that. And export. So at this point, if we do, just to see what environment variables we have listed. So we have my cert file, we have the device ID, and we have the host name. And we also have, if we do VC PKG, so we have also the VC package environment variable set as well. So looks like we're ready to go. So at this point, if we go back to right here. So we have the various environment variables that we need to set. And so you have to have these set before you compile the SDK, because CMake won't pull in environment variables after you've already configured it. So long story short, before you run this command, make sure you set these, whichever ones are necessary. So now we can just do CMake-d transport PAHO equals on and ... which is basically saying we want to use PAHO for a transport, and that will essentially turn on these samples. So I'm going to go back up to the root. So here you can see I don't have a build directory, so I'm going to go ahead and do that. Make directory build. I'm going to cd into that. So now I'm ready to build, aka this command right here. So cmake -d transport paho equals on dot. So now it's configuring the build files for me. So now I have all the build files ready to go. So all I'm going to do now is do --build dot. So I'm going to build all the files currently in my directory. And boom, we're ready to go. So you can see here, Paho, IoT Hub, C2D, telemetry, Twin. So all of the samples have been built. So now all we have to do now is .source them and essentially run them. So from the build directory in CMake somewhat copies over the directory structure from the repo itself. So you're going to find it in a very similar place. So /IoT or SDK, IoT, Hub, samples. And from here, you can see all the different ones that we can run. So let's just go in order of complexity. So telemetry is probably the easiest one. So let's go here, and then let's go to telemetry. So we're going to basically monitor the events as they come in. So I'm going to go ahead and do Paho telemetry. I'm going to run it. So it's sending. And here you can see the messages pop up beautifully. So we got 1, 2, 3, 4, 5. And there we go. So there's telemetry. As it says here, press enter to shut down. Basically, this sample just sends 5 telemetry messages and then prompts the user to shut down. So I'm going to go ahead and do that. Easy enough. So there's telemetry. The other one that is probably pretty easy to understand is cloud to device messages. So C2D messages, it's essentially telemetry, but the other way. So you send messages from the hub to the device. So let's go ahead and do that. So let's delete. C2D example. So it's going to connect. Waiting for activity. And at this point, all I can do is I can say, let's say hello build. And I'm going to send the message to the device here. And here on the sample, you can see C2D message arrived, hello build. So it basically prints out whatever the telemetry message is sent from the hub. So that one's also pretty self-explanatory. So you know, if I want to do it again, I can do it again. And hello build 2. Perfect. So there's a C2D example.
And then, Dane, you're using Bahal right now, but do we have any other examples for MQTT?
Do you mean other MQTT stacks? Or
yes.
Other MQTT stacks we don't currently.
Okay.
Yeah, so the way that we have the library structured, it allows people to sub in other MQTT clients that they may want to use. And with the Twin sample, I will go over essentially how it's structured and how a user can sub in a different MQTT stack pretty easily. You just have to sub in different, let's say, MQTT initialization functions, connect, all that kind of stuff.
Okay, perfect.
Yeah, but definitely can be done. We just don't have it here.
Okay, perfect. And before you jump into the next sample, just for folks who have worked with the CSDK before, I know that you mentioned where the GitHub repo is, but if there's any confusion with the naming, the original CSDK, not the embedded one, is under Azure IoT SDK C versus this embedded C SDK, which is, he showed the vanity link, but it's actually on GitHub, Azure SDK for C. So if that's confusing, because if you go to the Azure SDK for C, on the README it does say it is for the embedded C SDK, and then if you go to our Azure IoT SDK for all languages, it does link to that original C SDK.
Yes. So just so that everyone is I'll put this in more concrete terms. So the Azure SDK for C is right here. So in that we have SDK, we have other ones that teams are are writing out, but ours basically lives here. So it makes it easy, you know, in the future. You can see storage here. So in the future, when all of these other SDKs are built out, then all of the SDKs and all of the features that you may want to incorporate into your device are in one easy to find place. And you can also, you know, import them and link them to your projects much easier because, like I said, they're all living right here. But ours is, you know, special to us because we're the IoT team. So we're going to live in here for now.
Yeah.
Yeah, so I'll jump into, let's see. So we did C to D. We can do methods next. So methods are essentially a way for you to invoke some kind of behavior on a device from the cloud. So in some ways, it's somewhat similar to a C to D, but it has the behavior of having some kind of returned value or state or something like that. So you can invoke some kind of, you can think of like invoking a function call from the cloud on the device. So what I have here is the example for methods that we have written is a ping pong. So essentially, you have this basically waiting for activity. I'm going to go to the Explorer and go to direct methods, and I'm going to write ping, and I should get a response from the device saying pong with a successful status. So I'm going to go ahead and invoke that. And so right here, direct method arrived, status 200, which means everything is A-OK. And payload, the response is pong, so as it should. If I do something else, so let's say I write pong, which I don't have in the sample, there's no function called pong that I can call. I'll invoke it, and you can see here, direct method arrived, status 404, so it's not found, and I send back an empty payload. So that's basically showing what happens if you try to invoke a method that isn't there. And also, you can see in this output, here we have logged the response topic that we are going to send the response to. So let's say this is the incoming. Sorry, this is the incoming topic. So this is basically what has come in saying ping, and it sends a request ID so that when I send the response back, I can coordinate my response with the original method invocation. So that's direct methods. And the last one is twin. And I saved this one for the last because I'd like to go into, as you can see with this file, I'd like to go into depth about how this one works underneath. So that we can show twin has this behavior of inbound messages and outbound messages. So we can show the whole flow. And for those that aren't familiar with twin, essentially what it is a digital representation of some device's state. And it has these things called properties. One is desired and one is reported. So if you want, the classic IoT example is a thermometer. So if you want to have the device have a temperature of, let's say, 50, then in your desired properties field, you can set a temperature field to some temperature, and then it sends that update to the device. The device can do something, take some action on that updated twin. And in a lot of cases, it can, for example, send back the reported property. So let's say I set my desired property to 50. The device is currently reporting back that it is at 70. Over, let's say, every 5 seconds, it's sending back what its current state is. So maybe it's dropping from 70 to 65, and eventually, hopefully, the desired and the reported properties match in that case. So let's see. Let's go to the twin example, and I'll run it really quick, and then we'll go into a little bit more depth about how it works. So I'm going to go ahead and run it. And this one, like I said, because it's a little bit more complicated, has different options for the user. So press G to get the whole twin document. This will get the whole JSON for desired and reported properties. You can press R to send a reported property, which we have baked in here as some generic foo, I believe, at the top. Yeah, so reported property name is foo. And then what it can also do is it can receive updated twin documents to the device itself. So let's go here and let's start there. So let's take desired and let's add a property. So let's say temp, just for nice and short. And like I said, let's set it to 50, like I said in my example. So what's going to happen is I'm going to hit save, and then the service is going to send a message to the device stating you have an updated property field in your desired property. So I'm gonna hit save. And back here on the sample basically says a twin desired properties message was received. Here's the payload. So it says that the temperature field was updated to 50, and I sent a response back saying 200. I received it, everything's okay, which the service then acknowledges. So with that, I can get the whole twin document. So I press G, hit enter, and this says a twin message arrived, a twin get response was received, and here's the payload. So basically what this is saying is in the desired field, we have a temperature of 50. Reported is essentially empty because this is just a versioning system right here. So this isn't pertinent to us. And then I sent a response. The service sent a response back saying 200. So here we can then hit R to send a reported property. And so this, I sent a foo of 0, and you can see this updated by getting the twin document again. And here you can see this has changed from an empty, let me scroll up a little bit. Reported used to be empty, but now it has foo because I reported a property field of foo of 0. So that's kind of how the twin dynamic works, and I can hit Q to quit. So with that, what we can do is we can dive into the actual code and see how all this magic happens. So let's go to main. So this is basically where everything is going to start. Like I said initially, we're just going to go through this in the different steps. So this is essentially the initialization and configuration step. So as this says right here, it reads in the environment variables, and then it initializes what we're calling the Azure IoT Hub client. So we can go here, and for a really quick side note, we are using what is called an AZ span everywhere in this SDK, and I believe C# has a similar property or object that you can use. So it's essentially a struct that has a memory position and a certain length. And what this allows us to do is use memory that is not necessarily contiguous. We don't care if it was malloc. We don't care if it's static or anything. We can use memory in place as it is. So what this does is it gets all of the environment variables, and at the very end, it will initialize the client with what it says here. We have the struct, the AZ IoT Hub client that we're initializing. We're passing a span, so you can think of it just as a memory block with the IoT Hub hostname, the device ID, and a certain set of options that we're going to just use for default for now. So if I go back, go back to the bottom. So at that point, what we're going to do is we're going to get the client ID to use to connect to the MQTT client, which in this case is IoT Hub. So I'm going to pass in a span or a char buffer, and I'm going to get the length as well. I'm going to pass the length, sorry. And I'm going to get this back as a null terminated string to then pass into my MQTT client. And essentially here is where the PAHO specific functionality comes in. And this is where we're giving developers the option of choice. So with choice, you have some decisions to make about your MQTT stack. And so here we are creating an MQTT client with PAHO. So if someone wants to sub in something like Mosquito, or they have their own MQTT stack that they want to use already baked in the device, then they can sub essentially their MQTT specific stuff here to do maybe some initialization for their PAHO or for their MQTT stack. And as we keep moving down, we have a callback. We're setting a callback for any messages that are received from the device. So if we go up here, we have on received. So this is essentially invoked every time there is an incoming MQTT message on some topic. So we have the topic name, topic length, all that kind of stuff. So we can take some actions on incoming messages. So once those are set, we're then going to connect to IoT Hub via this function call right here, which if we go to definition, we're going to get the username to then pass to the connect. That's important for the authentication. We're going to pass that username here in the MQTT options, which is PAHO specific. So in this case, you might need to just sub in your own MQTT stack parameters. In this case, we're using X509, so the password field is null, and we're setting a trusted cert for the device cert. And here, like before with the initialization, we're now going to call a PAHO specific MQTT call. So we're going to connect to the service, passing the PAHO MQTT client with its options. And if everything goes according to plan, then this function returns 0, and we are ready to then subscribe to topics. So in this case, with Twin, we're going to go here. We're going to subscribe to various topics, which we have, as you can see, defined right here. We have these static topics that you can subscribe to. In this case, properties desired. So you can see, read the brief, gets the MQTT topic filters to subscribe to Twin desired property changes. So when I ran that sample first and I changed the desired field, this is the topic that comes in on. This Twin response is essentially a topic to receive any kind of response confirmations from the service. So if I send a GET response for the whole Twin document, that Twin document is going to be sent back on this response line. So once those are successfully subscribed to, at that point, we subscribe to topics, and now we're going to wait for activity. So this is the part of the sample where you could take an action like hitting G, hitting R, and all of those are handled then on, let's find it, on response or on received. So this is where a lot of the logic happens that I think people will be mostly interested in. Because what this essentially does is it takes in some kind of topic that was received, and it tries to determine if this is a Twin message. Because if it's just coming in on the MQTT stack, there's that separation between the application code and our code. So what the user can do is pass in the message topic that was received, and we have this helper function to help parse that to see if it is indeed a Twin message. So what this does is you pass in the MQTT client its span. So this is just, like I said before, this is just a memory pointer with some kind of length. And you pass in this Twin response struct. So this, if it gets populated, let's go here. If this is indeed a Twin message, then these fields will be populated for you. So you have a response type, which can be a number of enums, which we will go over. The status for the operation, the request ID as a span, and the version as a span. So here you can see the code saying if this succeeds, then printf Twin message arrives. So we have a confirmation that this is indeed a Twin message. And this switch case is particularly interesting because what it does is it switches on the response type from that struct. And here we have 3 different cases that it could be. So this could be a response type of GET. So this is a response from that GET message. So if I pull this up, so we have this press G, so requesting Twin document, a Twin GET response was received, which you can see here, and it essentially just prints the payload. So this is as a result of me asking the service for the Twin document. The case could also be that it is a desired properties. So this is a desired properties update. It's going to print out the payload, which you can see that was the initial one. Yeah, this temp 50 one. And then you also have the reported properties. So this is a response from me reporting properties from the device. So this is that R command. So a Twin reported properties message received. 204 is essentially saying, okay, I don't have a payload for you, because it's just confirming. So after that point, we want to free the message because this is PAHO, and it does malloc. Just as a quick side note, this SDK, because it is intended for embedded devices, does not use any mallocs. So the user has to supply all the memory that we use underneath the covers. So if you have a full solution that doesn't malloc any memory and you want it to be deterministic, you can do that, which was not the case for the original the original CSDK. So after that is done, basically it just sits here and it waits for any kind of received messages. And in the case that you're using a different MQTT stack, you can have a callback, you can have a while loop that does some kind of work polling. You can set it up however you'd like on your device. And like we said, because we offer that choice, it offers, the other side is that it requires that you make some decisions, but it makes it much easier to implement for other devices that we didn't necessarily support previously. So we kind of get out of your way in that case. So let's see, at the very end, when the user hits quit, we want to disconnect to try and gracefully disconnect from the service. So we're going to send that disconnect packet. And at the very end, we're going to destroy the MQTT client from PAHO so we don't leak any memory. So are there any outstanding questions maybe from Pamela or anyone else that I didn't go over? I think that pretty much covers most of the samples, and I think goes into depth pretty well about all the different features.
AMQP, could you talk about those protocols and what that means with the Embedded C SDK and support or maybe support in the future, or decisions made on just MQTT support?
Yeah, so in this case, we are fully embracing MQTT only. It is a widely used standard for embedded devices. And I think that it provides a very easy avenue for people to use this code and implement it in other solutions. So yeah, we're fully embracing MQTT and don't have any plans for AMQP at this point.
Okay, perfect.
Yeah.
And I think one of the other questions we get a lot is, does this Embedded C SDK require threads?
No, it does not. So in this case, like I said, you can have, this one uses threads, so it sets the callback and it will invoke that callback whenever something is received. But you can have a bare metal implementation that pulls and everything is ran in succession, and you can basically just pull asking to either send or receive some kind of message without any callbacks or any threads. So this is fully capable of being pure bare metal and being very, very simplistic.
Okay, perfect. And then one other question that we've been getting a lot is the Embedded C SDK. It sounds like it's portable to any supported platform. Do you want to give more information on if people want to port the Embedded C SDK and just more information how they can do that and which platforms they can do that to?
Yeah, for sure. So because we are this Embedded C SDK is a library and not a platform, what you can do is we have, I'll go into this header file, for example. We have a bunch of functions that make the development process easier to use our functionality with any stack that you may want. And what that means is we kind of get out of your way and you can call these from whatever platform stack you want. And we give some guidance on how to configure those other platforms to work with Azure IoT Hub, but there isn't really any porting that you need to do. There's no abstraction layers. There's nothing like that. You just have to configure your MQTT client in a way that complies with IoT Hub, which we have detailed documentation online for. Things like usually an MQTT port, I believe, is 1883. For IoT Hub, it's 8883. So as long as you set it to that, then you're good to go. We have, for example, let's try to scroll up to properties. Where is the, yeah, so these different topics that you subscribe to, we build those out for you so you don't have to configure these. So if you have an MQTT client, you can set those subscribe to topics. You just call this function first, and then you can pass that to your MQTT stack. We have all of the different functions for getting the MQTT client IDs and passwords and all that kind of stuff, SAS keys for people to use. So yeah, there isn't a whole lot of porting that necessarily needs to be done. There's a little bit of massaging that needs to happen in order to configure other MQTT stacks to work. But there is no abstraction layer, and and if anyone is familiar with the previous SDK, the XIO layer, all that kind of stuff, that's gone. So you only interface with that MQTT stack, and you don't have to glue it together with ours.
Okay, perfect. And I just want to go back real quick before jumping in to how people can get started and some links. When you go to the GitHub, repo for the Azure SDK for C.
Mm-hmm.
And then there's a section for IoT. And right now it's an embedded C SDK, but you're also saying that it will we have the C SDK there as well?
The original one?
Yeah.
So the original one is going to stay where it is for now,
Okay.
because they're kind of two different things, two different flavors for different scenarios. So we're keeping those separate and keeping all of the embedded SDK stuff here. And then if you still want to use the old one, it's still there available to use as it always has.
Okay, perfect. That's always the feedback that we get is where to go. There's so many locations to navigate to these repos. So thanks, Dane, so much for giving an overview of the samples. We also have samples for the device provisioning service. If you're interested in already using the device provisioning service or interested in using it with the Embedded C SDK, there's samples there.
Beautiful.
Is there anything else you want to say, Dane?
No, we do have this resources tab for any additional things that you may need. So any kind of Q&As, the Vanity link for the SDK, sharing the project that you may have, and the IoT show for this recording. So feel free to go to any of those if you need any additional help.
Thank you so much, Dane. And go ahead and check out the IoT show episode on the Embedded C SDK. We're going to continue to release new videos and of any of our new announcements and how to get started. As Dana said, we do have the IoT tech community. So if you have a project or you just want to connect with us, we're all on that tech community. So we want to hear your feedback. We want to see the projects you're working on, hear the challenges that you might have and how we can help out. And then as Dane mentioned, that Microsoft Q&A site, this is brand new. So it might be new to a lot of folks here, but if you have any questions about our products, we do now have an IoT support team that is on Microsoft Q&A where you can ask your questions, technical questions, business questions, any of that, and we're there to monitor that and have those discussions with you. So thank you so much, Wellington and Dane, and also everyone who's joining with this deep dive. Again, if you're watching this on demand, reach out to us on Tech Community if you have any additional questions. So thank you. Hope everyone has a great day.